Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class I will teach you how to solve the problem related to motion of the train. Motion, that is the chapter motion in a straight line. These are the IIT JEE question. Students, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT JEE exam and NEET exam confidently with a good rank. Now let's start about the class. The today class is about motion of the train. Mainly motion of train. So first question is this: suppose a car accelerates from rest at constant rate alpha for some time, after which it decelerates at a constant rate beta to come to rest. The maximum velocity v reached if total time taken is t. Second, then what is the maximum velocity? And also sometimes in some problem the distance travel. In some problem distance travel are to asked. Students are asked to find the distance travel. How to solve the motion of the train? Now a straight line. Suppose this is a straight line. Now the train, we know, starts with initial velocity 0, and before reaching the station, suppose from station A the train starts, and at station B the train stops. That is velocity equal to 0. Now before reaching the station B the train apply the brakes. So when he apply the brakes, the velocity is maximum because the train accelerate for the some time, and before reaching the next station he apply the brakes. So when he apply the brakes, at that instant velocity is maximum, and this path, the train moves this path with retardation beta. The train moves this part with acceleration alpha and this part beta. Now if the distance travel is x1, we consider x1, and this distance is x2, and time taken is t1 here, time taken is t2 here. So always consider in two part. Suppose this point is C. So first part moves with the distance will not be same. X1 not equal to x2. So first part the train moves with acceleration alpha, and second part with retardation beta. Distance travel is x1 and second part is x2, time taken t1 and t2. So how the problem will be solved? x1 equal to half t1 into alpha t1, that is put alpha t1 equal to vm by this. So x1 equal to this. Now given that total time t1 plus t2 equal to t, this is given. T1 plus t2, this is given. Now we consider the equation of path for CB. So for path CB, what is the equation? Equation x2 equal to vm t2 minus half beta t2 square. This is the equation, and also final velocity 0 equal to minus beta into t2. These are the two equations for the path CB. For this path CB, these are the two equations. Now from this we get vm equal to beta t2. So put vm at here, we get x2 equal to beta t2 equal to vm. So that is so x1 equal to this and x2 equal to this. Now we get vm equal to here beta t2, and also vm equal to alpha t1. Now this is one equation and this is two equation. Now from 1 and 2 we get we get alpha t1 equal to beta t2. We get this. Okay, now we have this t equal to t1 plus t2. So we have to write Vm, maximum velocity, in terms of t, alpha and beta. So how this can be calculated? Now from t2 from this we get t2 equal to t1. Now t1 plus t2 means equal to t. So from this t1 plus t2 equal to this. So from this we get t1. So t1 equal to this. So we get t1 equal to this. Now what is the maximum velocity? Vm equal to alpha t1. We get Vm equal to alpha into t1. t1 is this. So this is the answer. Get x2 equal to half Vm t2. Now if total x1 plus x2, which is equal to half Vm t1 plus half Vm t2, which is equal to half Vm t1 plus t2 equal to t. Now put Vm equal to this. So this is the answer. So this is the first draw the velocity time graph of the motion of the train. If this is velocity time, the graph will be this. Now this is the maximum velocity, and this slope is alpha and this slope is beta. And if this time taken is t1, this is t2, total time t equal to t1 plus t2 given. Now how will we get the Vm? Now from the figure we get that this is Vm, so alpha equal to Vm by t1. Okay, acceleration equal to slope of the velocity time graph equal to acceleration, slope of vt graph equal to acceleration. So we get this, and also beta equal to Vm by t2, because again beta equal to retardation. So slope of this line, slope means tan theta. If this is theta 1, this is theta 2, so tan theta 1 equal to slope equal to, which is equal to Vm by t1. Okay, similarly tan theta 2 equal to negative sign. Retardation means negative sign, negative slope. Just we consider here magnitude. Now alpha equal to this, beta equal to this. So Vm equal to alpha t1, this equal to beta t2. Now we given this, so t2 equal to, now put here from this we get this. Now what is the distance travel? Distance travel x equal to, what is the distance travel? By graphical method we know distance travel equal to area under vt graph. We know area under vt graph equal to distance travel. So this equal to half base is t. This is the time axis, so t into altitude here Vm. So half t into beta t by alpha beta t1 equal to this. So Vm equal to Vm, what is Vm? Vm equal to alpha t1. So Vm equal to alpha t1, that is put here t1, this we get Vm equal to this, alpha into t1, we get Vm equal to this. Now put here Vm, we get this, that is half alpha beta t square by alpha plus beta. So this is the distance travel. So by drawing the velocity time graph we can easily find maximum velocity and distance travel. Question number 2. This is also problem of motion of the train related. A train starts from a station and stops at the next station, moving along a straight line at a distance d meters. In the first part of the journey, the train moves with a uniform acceleration a meter per second square, and the second part with a uniform retardation b. Prove that the total time of journey equal to this. So here problem is like this way. So this is the path of the motion of the train just from rest. So this is station A and this is station B. So first part with acceleration A and second part with retardation B. Now the distance travel is x1, in time taken is t1, and here distance travel is x2, time taken is 2t. So it is given that given t1 plus t2, given total distance x1 plus x2 equal to d, x1 plus x2 equal to d, and total time taken, we have to find the total time taken t equal to this. What? In terms of a, b magnitude, in terms of a, b and d, in terms of a, b and d, total distance travel d given, acceleration a and retardation b given, we have to find total time taken. How this problem will be solved? So to solve this type of problem, first we write the equation for each part. For path AC, what is the equation? Equation is x1 equal to velocity starts here 0 and final velocity here 0. x1 equal to ut plus half a t1 square. Okay, and also velocity at c, vc, suppose velocity at here c, vc equal to 0 plus a t1. So we can write these two equations. Now that is in terms of vc, we get half a t1, that is vc, into t1, we get this, and for path bc, for path bc, x2 equal to what? vc into t2 minus half b t2 square. Okay, because b is the retardation. So now again another equation is v equal to 0 vc minus b t2. So vc equal to b t2 here, half b t2 equal to vc, t2 into vc. So this is half vc into t2. So x1 equal to this, x2 equal to this, we get, and vc equal to at1 and vc equal to bt2 we get. So x1 equal to this, t1 plus t2 equal to total time taken t, we get vc equal to 2t by t. This total time taken, we have to find t. Now what is vc? Vc equal to at1 equal to bt2. Now t1 equal to vc by a, again t2 equal to vc by b. So total time taken t equal to t1 plus t2, total time taken t equal to t1 plus t2, which is equal to vc 1 by a plus 1 by b. Now what is vc? From this we get vc equal to ab by a plus b into t. Now we have to find t. So vc equal to this and vc equal to this. So 2d equal to into t. So t square equal to 2d a plus b by ab. So t equal to root over this. So this way we can calculate the time taken t in terms of a b t, in terms of a b t. So this is the answer. Just we have to eliminate VC, and if we eliminate VC, then we get time taken T in terms of A, B and D. Problem is a train is traveling between two stations, distance x apart. During the first part, its velocity increases at a constant rate f1 from 0 to v, then remain constant for an interval and finally decreases to 0 at a constant rate f2. Prove that the total time for the whole journey is this. Question is, suppose the train starts from here, A, moves first part at a constant rate f1. Suppose this is acceleration f1 from 0, here velocity is 0 and reach at the point B, and velocity is here v. Velocity is here v. Velocity is v. Now it moves with constant rate, so velocity remains same for this part C. So here velocity is v, and then velocity decreases at the constant rate f2, that is retardation is f2. Prove that the total time taken and reach at the station D for velocity becomes 0. Prove that the total time taken for the whole journey is this. Suppose time taken to travel AB is T1, to travel BC is T2, CD is T3. So you have to calculate total time T1 plus T2 plus T3 equal to this. So you have to prove this. Total journey of the train, first part moves with acceleration f1, second part moves with constant velocity v, velocity equal to v, and third part before reaching the next station the moves with constant retardation f2, and finally velocity 0. So total time taken, you have to calculate total time taken this. So here also we write the equation for each part. To solve this problem, you have to write equation for each part. For path AB, what is the equation? Equation here we have to also consider the distance travel x1, x2 and x3. The distance are not given, but total distance are given in the question. Total distance x1 plus x2 plus x3 equal to x. This x is given. So for path AB, write the equation. Equation is x1 equal to 0 t1 plus half f1 t1 square. This is the v equal to 0 plus f1 t1. This is the another equation. So write two equations for each part, for each path. For path BC, now for BC the train moves with constant velocity, so x2 equal to velocity into time taken. And for path CD, distance travel x3 equal to v t3 minus half f2 t3 square, or v equal to final velocity 0 equal to v minus f2 t3. So we get these equations for each path. And this. Now how to calculate the total time taken? Now x1 equal to what? X1 equal to, we get half f1 t1 equal to v into t1. So x1 equal to half v t1, x2 equal to v t2, and also x3 equal to what? v t3 minus half f2 t3 equal to v. So this becomes v into t3, which is equal to half c equal to. Now we know x1 plus x2 plus x3 equal to x. So x1 equal to half vt1 plus x2 equal to vt2, x3 equal to half vt3 equal to x. So take common v by 2, we get t1 plus 2t2 plus t3 equal to x. So now we know t1 equal to v equal to f1 t1 and equal to f2 t3. So t1 equal to v by t1 equal to v by f1 and t3 equal to v by f2. So x equal to v by 2 t1 plus t3 v by f1 plus v by f2 plus 2 t2 2t2. So that is v so t2 equal to x by v equal to v from this we get t2 equal to x by v minus v by 2 half 1 by 1 plus 1 by 2. So we get t2 here. So t2 we get this. Now the required time taken is t1 equal to, we know t1 equal to v by f1 and t3 equal to v by f3 plus t2 only we get from this. t2 equal to x by v minus so from this we get x by v plus, if we take common v, then this become 1 by f1 plus 1 by f3 minus 1 by 2 f1 minus this is f2, sorry, this is f2 v by f2 1 by f1 plus minus 1 by 2 f2 which is x by v plus v by 2 1 by f1 plus 1 by f2. So this is the answer. This is the answer. Student, this is the end of the class. To get such type of video, subscribe my channel. Okay, thank you.